All right, so 8.3, we're going to learn about geometric sequences. So what makes this different than what we were doing yesterday is yesterday we had arithmetic sequence. To go from one number to the next, we add a constant number. Here, we multiply a constant number. So geometric sequence deals with multiplication. That constant number that we multiply to each term is our common ratio. And we can find the common ratio by dividing any number in our sequence by the number in front of it. So we could always divide our second term by the first term, and that'll give us the common ratio. So looking at example 1, we take the second term and divide it by the first one, so 4 divided by 2. That gives us 2, so 2 is our common ratio. And you can pick any term in the sequence to do that. If you pick the fourth term, so 324 divided by the term right in front of it, so 108, that would give us 3. And 3 is our common ratio. Even when the numbers get smaller, our common ratio is always with multiplying. So sometimes we're multiplying by a fraction, but you're never dividing. So it's always, always, always multiplying. If the numbers are getting smaller, you may just be multiplying by a fraction. So for this one, we would take 1/9, divide it by the term right in front of it, so negative 1/3. When dividing fractions, keep the first one, change to multiplication, and flip the second one. So this would give us negative 3/9, which simplifies to what?
Negative 1/3.
Negative 1/3. So our ratio here is negative 1/3. And whenever you have a negative ratio, your signs alternate from positive to negative, positive, negative, positive, negative. All right, next page. So the nth term of a geometric sequence has this form. It's written on top again just to show you that it's the first term being multiplied by the ratio. So in case this way is confusing, here you're just multiplying that first term by the ratio, and just the ratio has the exponent. So A1 is our first term. R is our ratio. And N is the term number. So in example 2, we have to write the first 5 terms of the geometric sequence whose first term is a sub 1 is equal to 3 and whose common ratio is 2. So we plug in what we have here. We have a sub n is equal to, our first term is 3, times our ratio, which is 2, to the power of n minus 1. So this is our formula, and we just plug in. We already were given a sub 1, so we just need to plug in a sub 2, a sub 3, a sub 4, and 5. He's asking us for the first 5 terms. So let's plug in 1. So a sub 1 is equal to 3 times 2 to the power of 1 minus 1. So just be careful here, because that exponent is only applying to the 2. It tells us what the first term is anyways, but I plugged in 1, so we'll find it again. What's 1 minus 1?
0.
0. And what is anything raised to the power of 0?
1.
1. So what's 3 times 1?
3.
3. Let's plug in 2. So we have 3 times 2 to the power of 2 minus 1. First thing we want to do is our exponent. 2 minus 1 is 1. So we have 3 times 2 to the first power, which is just 3 times 2, which is 6. Let's plug in 3. So we have 3 times 2 to the power of 3 minus 1. 3 minus 1 is 2, so 3 times 2 squared, so 3 times 4, which is 12. No? Yeah, 12. A sub 4. So we have 3 times 2 to the power of 4 minus 1. 3 times 2 cubed. 2 cubed is 8. What's 8 times 3? 8 times 3? 24. And then the fifth term, so a sub 5. 3 times 2 to the power of 5 minus 1. So 3 times 2 to the fourth power. 2 to the fourth power is 16, so it's 3 times 16. $48. Awesome. So we can see here that we just multiply by 2 each time we go to the next term. Times 2, times 2, times 2, times 2. Which makes sense because our common ratio is 2. But on the test and quiz, so your quiz is Friday, on the quiz you have to show your work. So I need to see you plugging in each number for n. So you have to show your work. You can't just start with 3 and then multiply by 2 each time. So I understand that you could do this without showing any work. You can just write 3 times 2, which is 6. So 3, 6, 12, 24, 48. It's not that hard to do in your head, but I need to see your work. So I need to see this. Example 3 says find the 15th term of the geometric sequence whose first term is 20 and whose common ratio is 1.05. So our first term is 20, so this is a sub 1, and our common ratio is 1.05, so this is r, and we have to find the 15th term. So we just want to plug everything in. We're looking for a sub 15. A sub 1 is 20 times r, which is 1.05. What would our n be? 15. So 15 minus 1. So we have a sub 15 is equal to 20 times 1.05 to the 14th power. And then we can just put this into our calculator. So a sub 15 is 39.59. Is that what you got?
Well, it's 0.598, so I just said
Okay.
60.
Yeah, same thing. 0.598. All right, example 4. We have to find a formula for the nth term of the following geometric sequence and then find what the 9th term of the sequence is. So with this equation, we're looking for a sub 9. Do we have a sub 1? What's our first term? 5. Perfect. 5. Do we know what our ratio is? Awesome. We just take our second term, divide it by the first term, and that gives us 3. So 3 is our ratio. And then the n we're looking for is what? 9. So 9 minus 1. So a sub 9 is equal to 15 times 3 to the power of 8. And we just put this into our calculator. Awesome. 32,805. All right, so example 5 is probably the hardest example that we would do from these 3 sections that we've been doing. It's going to give us 2 terms in our sequence, and we have to find another term. So it tells us that the fourth term is 125, so a sub 4 is 125, and the 10th term is 125 over 64, so a sub 10 is equal to 125 over 64. We did a problem like this with our arithmetic sequences. So when we had arithmetic, I think I spelled that wrong, but it's fine. When we had our arithmetic sequence, it gave us like a sub 4 was 16, a sub 20 was 100. This we did on Monday. And then we had to find how many terms are in between these two, so 16 terms. And then we took the one that was farther from 0, so a sub 20 is equal to a sub 4 plus 16 times d, which was our common difference. We're doing that same thing for geometric, but just this formula is different because our geometric formula is different. So for geometric, how many steps are in between 4 and 10? 6. Just 10 minus 4. Which term is farther from 0? A10. So we start with our a sub 10. That's equal to our a sub 4. And now since this is a geometric, what makes it a little bit different is we multiply our ratio to the exponent of how many steps we need, so 6. We have what our value of a sub 10 and a sub 4 are, so we just need to plug those in. So we have 125 over 64 is equal to 125 times r to the power of 6. So we are solving for r. What do we need to do to solve for r? Awesome. Divide both sides by 125. What do we do when we are dividing with a fraction? Keep change flip, so we change it to multiplication. This would be 125 over 1, so we flip it to be 1 over 125. So it's 1 over 125 times 125 over 64. Awesome. 125s cancel out, so it's 1 over 64. And that's equal to r to the 6th power. What do we have to do next?
You square rooted by 6.
Take the 6th root of both sides. What's the 6th root of 1?
1.
1. And what's the 6th root of 64?
2.
2. So 1/2 is equal to r. So we found our r, but this question's actually asking us for a sub 14. We got to find the 14th term in our sequence. So we could plug this in into our original formula, which is a sub n is equal to a sub 1 times 1/2 to the power of n minus 1. But we don't know what the value of our a sub n is, and we don't know what the value of our a sub 1 is. So what we can do is we can actually do the same thing we did here, but instead of a sub 10 and a sub 4, we're going to use a sub 10 and a sub a sub 14, because 14 is what it's asking us for. So for a sub 10 and a sub 14, which one is farther from 0? A sub 14. So a sub 14 is going to be equal to a sub 10. What's our r? 1/2. We just found that. So 1/2. What would our exponent be? How many steps from 10 to 14? 4. And we have what our a sub 10 is. That's 125 over 64. So we just plug that in. So we have a sub 14 is equal to 125 over 64 times 1/2 to the power of 4. Then we just evaluate. What do you get when you put this into your calculator? (125 over 1,024). What do you get when you divide them?
0.122.
0.2122?
0.122.
0.81. What did you say? Like this?
0.122.
There we go. Like this?
Yeah.
Awesome. So you can leave your answer either way. Both of these work. Next page. So next we're going to be finding the sum of a finite geometric sequence. What does finite mean?
Limited.
Limited, or that it ends. It's going to give us a starting number and an ending number. So this is our formula to find the sum of a finite geometric sequence. Our a sub 1, actually I'll explain it on the next page because it's rewritten there. Yeah, so I'll explain it here. So our a sub 1 is our first term and it includes the ratio. So this is the first term, ratio included. The n is our ending term, or our ending number. So it's going to be the number on top of our summation here. So this number. So it's our ending number is our n, and our r is our ratio. So the ratio is just what the exponent applies to. So our sum of our sequence here, so it'll be s sub 12 is equal to a sub 1, which is this whole thing here, so 4 times 0.3 times 1 minus our ratio, so 1 minus 0.3 to the power of 12 over 1 minus our ratio, which is 0.3. Everybody with me so far?
Yes.
Awesome. So once we get here, once we plug everything in, we can just put the rest of it into our calculator. We have all values here. We're not trying to do anything crazy. We're going to put this into our calculator. The hardest part is just following PEMDAS when putting it into the calculator. So what I would suggest is doing 4 times 0.3 first. and then multiplying that to 1 minus 0.3 to the 12th power over 1 minus 0.3. So if you do it in this order, I think you should be fine. You just got to be careful when putting it into the calculator. $11.71.
1.71.
Thank you, Leo. Sorry, it's kind of hard to hear on Zoom. 1.71. So next we have the sum of an infinite geometric series. So infinite means that it never ends. We will see this infinity sign, or it'll give us a sequence with dot, dot, dot. So that just means that never ends. This is our formula to find the sum of an infinite geometric series. A sub n is our first term, not including the ratio. And then r is our ratio. All right, so our last example. Two more here. So our sum of our series is going to be a sub 1, so not including the ratio, so we don't include this 0.6 here. So it's 4 over 1 minus our ratio, which is 0.6. Then we just put this into our calculator. What do we got? Four over 0.4, which is 10.
10.
Thank you. All right, let's do the last one. So we need to know what our a sub 1 is, and we need to know what our ratio is. Here it just gives us a sequence of numbers. Do we know what our a sub 1 is? What's our first number here for b? 3.
3.
All right, and then how do we find our ratio? Second number divided by the first. So we have 0.3 divided by 3. What's 0.3 divided by 3? 0.1. So our ratio is 0.1. So then we just have 1 minus 0.1 on the bottom. What do we get when we put this into our calculator? .33 repeating. Awesome.